Team Linspace. The creation of HDPE blocks comes with many imperfections of the surface. When using the Sherline mill, it can be very useful to know where these imperfections are. The goal of our project is to design a way of measuring the imperfections of the HDPE block from a mounted piece on the Sherline mill and showing this data feedback. Our major learning outcomes were understanding the design process. For moving from identifying the opportunity, seeing that the HDPE block has its imperfections and they can be fixed, to understanding the opportunity. We have the need to measure these imperfections in a way to connect to the Sherline mill. Next, the conceptual design, using the pictures and several ideas to explore. Then, moving to detailed design, settling on infrared lights and a solid model. Next, the fabrication using the MakerBot to create parts and creating our circuit boards. Validation was done through the tests and making sure that our X, Y, and Z measurements were accurate. Another major learning outcome was the general use of circuit boarding and coding. Our project included the use of infrared lights and receptors. We partnered this with the use of the Arduino. This required us to become very comfortable with circuiting and the manipulation of code for our personal use. Once we decided we would be using infrared light systems, we began compiling the circuit board into small, easily usable pieces. This shows one of our 3 infrared lights and receptors soldered together. This part of our design is the casing for the X and Y plane infrared light sensors. The casing was made in 2 pieces. First, the long piece with tubing for the wires, and then the cap to seal the small circuit board tightly inside. Our last part of the project served several purposes. First, it had the casing for the placement of the Z-plane circuit board measurement. Secondly, it had a metal bit that attaches to the Sherline mill inside the collet. Third, it had 2 slots to connect the X and Y plane parts that have the ability to slide back and forth. The combination of the circuit boards and printed parts all connected to the Sherline mill through the collet as such. We wired everything through the plastic and then to the Arduino. This then sends an infrared light that bounces off the plastic to the receptor. A measurement is done by changing in voltage, which can be converted to distance. Because we found our voltage relationship to distance to be an exponential graph instead of linear, our coding for the Arduino had to be altered. In setup, wait 5 seconds, then take the reading of X, Y, and Z. Store these values. Declare these variables at the top where you define the pins. When the reading in the loop, subtract the value from the new reading. Then write to screen. This fixed our problem. As seen in the video, each rod extends to one side of the HDPE block and has infrared sensors to test the X, Y, and Z planes. These are all connected through the Arduino and then coded to the computer with each individual feedback for the different sensors. We set an initial target of being able to record the distance in X, Y, and Z planes. This we found was a very achievable goal, with many possible methods. After deciding to use infrared, we decided we would like to achieve an accuracy of 0.01 inches. Our results were up to 0.02 inches, with our best accuracy when the infrared was between 0 and 1 inch away. We found this a good accuracy to achieve without a budget. After reflecting on our design process, we learned how much time is required to make a team project like this work. Between correlating meeting times, overcoming road bumps, printing parts, math modeling, and making the overall project work, it came out to take much more time than that of most classes' homework load. We also discovered teamwork is vital to making the project work, and everyone's ideas can come into play. Never reject anyone's ideas because they can all become very helpful. Last, we learned that organization is key. Between documenting everything done and seeing how messy the senior design suite can get, we found staying neat was crucial to our work. Overall, we just needed to stay smart.